The next section of the medulla oblongata is at the level of the pyramidal decussation. That is the level of the motor decussation. If you can remember, previously I discussed about the cross-section of the spinal cord at the level of its open part and also the level of the sensory decussation where the medial meniscus begins to form. So at that level, I discussed that cross-section. So now the section is about this, level of the pyramidal decussation. So if you now take a cross-section of this medulla oblongata at the level of pyramidal decussation, what it means is that, if you can remember, we said that fibers from the midbrain, they pass down as our, cerebral peduncles. They now come down, pass through the pons, descend through the pons, and then they come down. They conglomerate together by the side of the midline to form these pyramids. So now, the most anterior part here is our pyramids containing these corticospinal tracts. So at the level of this medulla oblongata, these fibers, as they descend from up, they now go backward to the opposite side. They descend from above, and the fibers, they now bend. They have to go backward and then laterally. They pass backward and then laterally to the opposite side, and then descend down as what we call lateral corticospinal tract. So this where this tract from this, if this is the right side, this is the left side. So from this right side, it goes to the left side and then descend down as what we call our lateral corticospinal tract. Similarly, that of the opposite side also passes backward and then laterally to form that lateral corticospinal tract. So most of these corticospinal fibers, as they descend from the cortex down, we said about 80 to 85% of these fibers, they crisscross to the opposite side. Are you clear? The remaining 15 to 20%, or you can say 10 to 20%, they remain uncrossed as what we call anterior corticospinal tract. Are you clear? So we have seen that the lateral corticospinal tract are nothing but the crisscrossing fibers of the corticospinal tract, about 80 to 85% of them crisscrossing to the opposite side to form this tract. The remaining 10 to 15%, they lie in the anterior funiculus of the medulla and the spinal cord to form the anterior corticospinal tract. So those are the uncrossed fibers. So we have seen that. So laterally, you can also see our other structures the way we saw in the other sections, our olivary nuclear complex. And then when you now go by the lateral side, you can also see our dorsal spinocerebellar tract and also ventral spinocerebellar tract on that side. And so when you now come inward like this, you're also going to see this, our spinothalamic tracts. We have our lateral spinothalamic tract, and then we have our anterior spinothalamic tract together with our tecto spinal tract, so that as they ascend up, they form our spinal meniscus that we discussed before. So just anterior to this lateral spinothalamic tract, we have our cerebrospinal tract by the side, and also we have vestibular nucleus. So the vestibular nucleus is lying just behind this inferior olivary nucleus, and so this vestibulospinal tract is, a kind of tract that is coming from the vestibular nuclei. You get my point? We have our vestibular nuclear complex. So those ones, to maintain equilibrium, and it is all reflexes. We said vestibulocochlear nerve is responsible for the maintenance of equilibrium, the vestibular component of that nerve. Are you clear? For balance and equilibrium. So from those nuclei, the fibers, as they come down, they form this tract, so that finally they now go into the cerebellum. You get it? So this, as they go into the cerebellum, they now give information to the cerebellum regarding, maintenance of the equilibrium reflexes and what have you. So just behind the lateral corticospinal tract, we have our own medial longitudinal fasciculus. And so what I should also tell you, all those structures that we have seen in the previous section with regard to the section of the medulla at the level of the sensory decussation, I discussed about the three sets of nuclei, our own gracile nucleus, our own cuneate nucleus, and the other one is the spinal nucleus of the trigeminal nerve. So we also have the fasciculi lying behind this nuclei. We have our gracile fasciculus, we have our cuneate fasciculus, we have the tract of the trigeminal nerve. So all this, connect with its own corresponding nuclei like that. Are you clear? But now here, this is not the level of the formation of the medial lemniscus. So as they connect, the second order neuron passes up, and then it now forms at that level of the sensory. That is why you will not see that formation of the medial, you will not even see the medial lemniscus here presented. Are you clear? So that is only you can see when you do, but other things that are also important with regard to this olivary nucleus complex, just by the side of it, there are two tracts that one can see. That's what we call olivospinal tract. That means from the olivary nucleus, fibers descend down to go into the spinal cord. You get my point? So also, fibers from the spinal cord, they ascend down to go into the olive. So you have olivospinal and spino-olivary. Are you clear? So that it is vice versa. So you have descendant fibers from the olive, you have ascendant fibers from the spinal cord into the olive. All these are, to regulate movements, perception and what have you, which we'll discuss later on when we come to discuss the ascending and descending pathway in the, brainstem or in the spinal cord. So by and large, actually, these are what you are going to see. And in all the sections, either sections of the midbrain, sections of the pons, sections of the medulla at any level. Probably, maybe I didn't write it or I didn't mention it in the previous lectures. You are going to see all this sympathetic tract coming from the hypothalamic. If you can remember the hypothalamic nuclei, you get it. All those ones responsible for our autonomic nervous function. From the anterior hypothalamic nucleus and posterior hypothalamic nucleus, we said that fibers that they pass down, from the brain there, come down within the brainstem until they go into the cranial outflow of the parasympathetic and the sacral outflow of the parasympathetic, if you can remember that. So those ones, they descend. If you can remember, I also made mention about the reticular formation. That I said there are scattered nuclei along the whole length of the brainstem. So all this can be seen, the reticular formations, the scattered nuclei, they can be seen here. Are you clear? And so this is the sympathetic tract, from the posterior hypothalamic nucleus. Are you clear? For our own sympathetic response and what have you. So now those ones can be seen in all the sections. Reticular formation, sympathetic tract, and so on and so forth. So this is by and large what you people should get to know when you're asked to write the internal sectors of the medulla oblongata at the level of pyramidal decussation. So we have a break before we take our final lecture, back aspect of the medulla, of the midbrain.